Okay, so let's get started on completing the square to solve for our quadratic functions. We're going to use this example and go step by step, and then we will do a few other examples. So in all, there's about 7 steps. Keep in mind what we're trying to do is create a perfect square trinomial on the left side, a constant on the right side. And also, when we create our perfect square trinomial on the left, we are going to want to have the quadratic term coefficient be 1. We will get to that. So here's step 1. And remember, at any time, pause the video. This is quite a process. So step 1, we want our constant to be on the right. So we're going to add 16. Back up here. We're going to add 16 to both sides. And when we do this, we get 2x squared minus 4x equals 16. Now, notice I left a space here. I just make this a habit because we are going to try to create a perfect square trinomial on the left side, which means we need a constant here. And yes, if there's already a constant there, you go ahead and move it to the right side. The second thing is our a value needs to be 1. So I need to factor out this 2 just on the left side. So I'm going to factor out a 2, and I have x squared minus 2x equals 16. Now notice, I did not factor the 2 out of this 16. You only factor out the a value on the left side, and you only factor it out if a is not 1. If a had already been 1 and it was just 1x squared, I would not have to do step number 2. Okay, now, like I said, I've already prepared a space right here. And so I am going to force this expression to be a perfect square trinomial. And the way we're going to do that is we're going to use this formula, C equals B over 2 squared, just like we practiced in the previous video lesson. So we're going to take a look at our new B value of -2. We're going to take half of that, which is -1. So C is half of -2 is -1, and then we square it. So my C value is +1. So step number 4, we have 2x squared minus 2x plus 1. Now to keep our equation balanced, whatever value I add on the left, I also must add on the right. And that's where we're going to take a look at step 5. So we had 1 here. So I actually added a value of 2 on the left because this is really 2 times 1. So here, make sure you take note and write this in your notes that if I have factored out a factor, I need to multiply this needed value, which was 1. Now we have a perfect square trinomial, and I need to add a value of 2 on the right. 2 times 1 is 2, so I have added a value of 2 on the left, so we have to add a value of 2 on the right. Now, we need to factor the left side and combine the right side. So I'll bring down my 2, and now we're going to factor. So remember the 3 steps in factoring a perfect square trinomial, which we created. You take the root of your quadratic, the sine of your linear, and the root of your constant and its quantity squared equals 18. Now I have a problem in which I have a square, so we're going to use the square root method. This is the goal in completing the square. So now we're going to solve for x. So we're going to divide each side by this 2. We have x minus 1 quantity squared equals 9. We're going to take the square root. Keep in mind we're solving for x. And I have x minus 1 equals negative 3, and x minus 1 equals the positive 3. 1 root is negative 2. The other root is 4. These are the two x-intercepts. So that was quite a process. So let's go through this a few more times. First step, make sure the c value is moved to the right side. So we're going to add 1. We want a blank canvas, so to speak. We're going to create our own perfect square trinomial. The second step is to make sure our a value is 1, and it is. So we do not need to factor anything out. You want your quadratic to have a coefficient of 1, which we do. The next thing is to prepare a space, which I already do, to create a perfect square trinomial. So we're going to force a perfect square trinomial by using our formula. C is half of b, and then we square it. So here we go. We're going to take half of negative 8 and then square it. And we have a positive 16. So this actually was a value of 16 added to the left, so we must add 16 to the right to keep it balanced. Now I have a perfect square trinomial, so we're going to factor the left side and combine the right side. I take the root of my quadratic, the sine of my linear term, and the root of my constant quantity squared. Now I solve for x. I use the square root method. I want to take the square root of both sides, so I have x minus 4 equals negative 3, and x minus 4 equals positive 3. And now we simply solve for x. So one root is 1, and the other root is 7. Let's try a second example. Step 1, make sure that the constant given is moved to the right. So I'm going to add 36. The second step, make sure your a value is 1. It is, so I do not have to factor anything out. Make sure you have created a spot for the needed value to make a perfect square trinomial. To create a perfect square trinomial, you take half of b and square it. Half of 4 is 2, and 2 squared is 4. We added a value of 4 on the left, so we must add that same value on the right to keep our equation balanced. Now we need to factor the left and combine the right. To factor a perfect square trinomial, take the root of your quadratic, the sine of your linear, and the root of your constant. Now solve for x using the square root method. We're going to take the square root of both sides. We have x plus 2 equals negative 7, and x plus 2 equals positive 7. We're going to solve for x. We're going to subtract 2. One root is negative 9. Our second root is positive 5. Our parabola crosses the x-axis at -9 and +5. (6x² minus 12x minus 14 equals 4). Step 1, move your c value to the right side. We're going to use the inverse operation and add 14 to both sides. The second thing, our a value needs to be 1. So I'm going to factor out a 6 only on the terms on the left side. I've made a space for my constant that's going to create a perfect square trinomial here. That formula is taking half of c, -1, and squaring it, and that's +1. Whatever value we added to the left, we must add to the right. This is not a value of 1. In reality, it is 6 times 1. So I actually added a value of 6. So we must also add 6 on the right. Now we need to factor the left and combine the right. To factor this perfect square trinomial, I take the root of the quadratic, the sine of my linear, and the root of my constant, quantity squared. Now we're simply going to solve. First, we must divide each side by 6. Now we need to take the square root of both sides. We have a root of -2 and a root of +2. Now simply solve. And our two roots are -1 and 3. Let's try one more. Step 1 is move the c value using the inverse operation. So we're going to add 76. Step 2, make sure our a value is 1. If it is not, factor that leading coefficient from the two terms on the left side only. Step 3, make sure that you prepare a space for your perfect square trinomial. To get that perfect square trinomial completed, to get the c value, you take half of -8, which is -4, and you square it, and it's going to be +16. Now, because we added a value of actually 32, this is 16 times 2, so this is really a value of 32 been added on the left. We have to add that also on the right. Now we need to factor the left side. We have a perfect square trinomial that we created. We take the root of the quadratic, the sine of the linear, the root of the constant, quantity squared, and now we combine. 108. Now we solve. We're going to divide each side by 2. X minus 4, quantity squared, equals 54. Take the square root of both sides. We have x minus 4 equals negative, and this is really broken down into 9 times 6. We take the square root of 9, which is 3, radical 6, and then we also have the positive root. We're going to add 4. We cannot combine this 4, this integer, with this radical expression, so we simply write it 4 minus 3 radical 6. We add 4 to the positive root, and we have x equals 4 plus 3 radical 6. And I always put my integer first and then the radical expression. And if you were asked to plot these on a graph, you would simply just use a calculator to get an estimated decimal.